Welcome to another Algebra 2 lesson. This is 4.7. Our objectives today: describe transformations of polynomial functions, write transformations of polynomial functions. We studied transformations in chapters 1 and 2, and they kind of went away for chapter 3. Well, they're back. Transformations. Describe the transformation from the parent function. So we're going to start with some warm-up problems. You might want to just watch and stick with me mentally instead of writing these down, because there's 8 of them, and we're going to go through them pretty quick. Remember, when we multiply, we are doing a vertical or horizontal stretch or shrink. Multiplying the stretches and shrinks, adding or subtracting are slides, translations, left, right, up, down. So we are multiplying by 5. This is a vertical stretch by 5. So for now, we're just sticking with functions we have seen before in the past in chapters 1 and 2. Number 2, we are multiplying by 1/3. It's a quadratic function, so its parent function is x squared. We're also multiplying by a negative. So this one, there is a transformation for this, the negative, and a separate one for the 1/3. So what transformations, what happens when you multiply by a negative? It's called a flip or a reflection. Is it in the x-axis or y-axis? This one's in the x-axis. If it was tucked in with the x, it would be over the y-axis. So we have a reflection over the x-axis, and then when we multiply by the 1/3, that is a vertical shrink by 1/3. All right, what do we have next? Let's see, what does the 2 do? That is a vertical stretch. Vertical stretch by 2. Notice, all of these are multiplying, so they're vertical stretches or shrinks. Only if they were tucked into parentheses or if the number were inside the absolute value, then it would be a horizontal stretch or shrink by the reciprocal. But we don't have that here. So this one, pretty much, number 4, this is a reflection over the x-axis again, except for it's an absolute value graph this time. And it's a vertical shrink by 1/2. So what did all 4 of these have in common? They all had a vertical stretch or shrink because they all were x times something. They were all being multiplied by something. This had an x squared, this had an absolute value of x, but you were still taking a parent function and multiplying by something. For transformations, describe the transformation of f of x equals x squared represented by g, then sketch a graph. This time we are adding and subtracting. Adding and subtracting are translations. Those are when they slide left or right, or up or down. So if we think about that x minus h quantity squared plus k, we learn transformations. H and k was your vertex. H is your horizontal shift left and right, the opposite of what it looks like it should be. So minus a number is going to go right, and plus a number is going to go left. But they are the HK is your vertex. So it tells you where your new vertex point is, and that's going to help us a lot with our graphs. All right, so this, let's write down the vertex. The vertex is, there's nothing tucked in with the x, so that's a 0. And k is out here, so it's 0, 5 for a vertex. Think about where 0, 5 is. So your standard parabola, where does that shift? Our standard parabola, the y equals x squared, shouldn't call it standard. The parent function, 1 squared is 1, 2 squared is 4. So we go over 1 up 1, over 1 up 3, over 1 up 5, and then graph what's symmetrical to it. This is our y equals x squared. We always want to do the parent function also. Over 1 up 1, over 1 up 3, over 1 up 5. That's that 1, 3, 5 pattern for the slope, the rate of change. Okay, so there's our y equals x squared. Now for the graph of x squared plus 5, it's going to be the same pattern, but it's shifted up 5. Over 1 up 3, over 1 up 1, over 1 up 3. There's our new parabola. Describe the transformation. We didn't do that yet. We could just say up 5. Or if we want to use all of the important vocabulary. So when you're doing big ideas assignments, you probably want to say vertical translation up 5. Vertical translation up 5. How about number 2? Write down your vertex. HK, x minus h, so our h is 1. There's no plus a number outside the parentheses, so that's a 0. So we have vertex 1, 0. And then our parabola, over 1, up 1, over 1, up 3, over 1, up 5. Do it again, over 1, up 1, over 1, up 3, over 1, up 5. And draw your parabola. I'm not going to draw the parent function this time. We drew it on the first graph. And then which direction did that shift? That went 1 which way? Moved to the right. So that was right 1. On big ideas, you're going to have to be very technical, use all the vocabulary. This is going to be, is this a vertical or a horizontal translation? Moving side to side. Horizontal translation. Right 1. And the next one, number 3. Okay, pause your video. Write down what you think the transformation is and what the graph would be for 3 and 4. On your mark, get set, go. Pause your video. My answers will magically appear. Here they are, the rest of the answers for 3 and 4. Remember HK, H is in the house. That is your horizontal translation, left or right. K is kicked out. K is out here. K goes vertical, up or down. Some people say flag kite. Kites go up and down. K is the one that goes up and down. All right, let's see how this applies to our polynomials we're working on for chapter 4. H is in the house. That is your horizontal translation. Graph shift left or right. K is kicked out. It is your flag kite. It is the K. Added on to the end. That'll make it go up or down. Multiplying just x by a negative will give you a reflection over the y-axis. Multiplying the entire function by a negative gives you a reflection over the x-axis. And then stretches and shrinks. Stretches and shrinks are multiplying. If you multiply just x by a number, you get a horizontal stretch or shrink by the reciprocal of what is next to the x. And then if you multiply the entire function by a number, you get a vertical stretch or shrink. So h is in the house. Horizontal is inside the h. The horizontal translation is inside. The horizontal stretch and shrink is inside the parentheses or inside the absolute values, inside whatever type of function we're working with. Notice all of these examples have an x to the 4th. They have a 4th power. We are dealing with polynomials that could be an x cubed, x to the 4th, x to the 5th, but the transformation rules still apply. Example 1. Describe the transformation of f of x equals x cubed, represented by g of x. Then graph each function. All right, g of x is the quantity x plus 5 cubed plus 2. So still think about our hk as, it's not our vertex point, but it's still our starting point. Instead of 0, 0, it has shifted to the left 5 and 2 up. So the new hk is negative 5 and 2. So we want to write that down. That is a horizontal translation. Left 5. And which way does it go to? That is a vertical translation. Up 2. So there's our transformations. That's how we get to negative 5, 2. It's another reason why I like to use that. And write that down, even though it's technically not a vertex, it's still going to be a point on our graph. Negative 5, 2. It's going to be an important point. But before we graph this, we really want to take a look at the parent function, x cubed. If we make a table for y equals x cubed and use x as negative 2, negative 1, 0, 1, 2, and cube those numbers, we can get the start of our parent function graph. So negative 2 times negative 2 is positive 4, times another negative 2 makes it negative 8. So a negative number cubed is going to give us a negative number. So let's graph these. Negative 2, negative 8. Negative 1, negative 1. 0, 0. 1, 1. And 2, 8. So I like to think of a cubic graph as kind of like a half a parabola and then another half of a parabola. It kind of helps me visualize the shape. Notice it goes through 1, 1 and negative 1, 1 and 0, 0. Those are 3 points you always want to make sure you've got correct. It helps to see the general shape, though, if you keep going one more. Now, let's look how we can build the table without having to use decimals, without having to go to the graphing calculator. We want to subtract 5 from the x values. Think about it's usually an x minus h. So if we subtract 5 from each one of those x values, negative 2 minus 5, negative 1 minus 5, 0 minus 5, 1 minus 5, 2 minus 5. So the h was a negative 5. So we did x minus 5 to get those. What do you think we're going to do to the x cubed? What do we do to the entire function? We add 2. So if we add 2, that's the k value. So up here I put the h down, here I'm going to put the k. Add 2. K is a positive 2, h was a negative 5. So I'm adding those numbers together. So negative 8 plus 2, negative 1 plus 2, 0 plus 2, 1 plus 2, 8 plus 2. Let's graph those numbers. And our graph should be just like the one we had, but shifted left 5 and up 2. So here we go. When we graph these points, we're going to use the very outside. Negative 7 goes with negative 6. Negative 6 goes with 3. So back 6, up 3. Oh, negative 1 plus 2. Remember, I changed that sign. Negative 1 plus 2. What is negative 1 plus 2? Positive 1. Okay, so negative 6 goes with positive 1. Almost ruined my pattern. That's all about patterns. Negative 5 goes with 2. Oh, that's the point I already graphed. Negative 4 goes with 3. Negative 3 goes with 10. So then we draw, I think, half parabola, half parabola. Get those curves going. Kind of missed that one just a little bit. But there's our basic graph. Same shape, shifted to the left 5 and up 2. And we didn't use decimals or a calculator. Woohoo! All right, that's example 1. Example 2. We have 2 graphs to try. Describe the transformation of f represented by g, then graph each function. Let's look at problem A first. So this is 2a. X to the 4th power. We're going to have to get a basic shape of x to the 4th power. We'll use -2, -1, 0, 1, 2. So that'll be the parent function, parent polynomial function. And then the g of x, we are going to multiply by negative and by 1/4. So we're going to get a reflection and a vertical shrink by 1/4. When we're doing that, we're multiplying the f of x by -1/4. So let's first find our parent function numbers. So -2, if we're putting in a -2 into the parent function, that's -2 to the 4th. So multiplying 4 negatives together will give us a positive answer. 2 times 2 times another 2 times another 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. That is a positive 16. And then next we try -1 to the 4th power. So we put in -1 to the 4th power. 1 times 1 times 1 times 1. Oh, but they were all negative. 4 negatives multiplied together is always a positive, and 1 times 1 times 1 times 1 is 1. And 0 to any power? 1 to the 4th power, 2 to the 4th power. Let's draw our parent function. Put it on the graph. Sixteen's off our graph, so we'll just draw one off the graph. Try to draw a smooth curve. Line's a little wiggly. But now for our new function, multiply all of these f of x functions, the y values, by -1/4. 16 times -1/4. 1 times -1/4. 0 times anything. 1 times -1/4. 16 times -1/4. 1/4 of 16 is 4. When you're multiplying by a fraction, if you just think of the word of, 1/4 of 16 helps you get to that answer. Let's graph those. Now we're using the top and the bottom. So -2 is our x when our y value is -4. So -2, -4. -1 goes with -1/4. Just estimate. 0, 0. 1 -1/4. And 2 -4. Draw your graph. Okay, we've got our graph. Let's check the directions. What else did it ask us to do? Describe the transformation. So we had 2 transformations, one for the multiplying by 1/4 and a separate one because it was negative. The negative makes it flip. What do we call a flip? That is a reflection over which axis? Yep, x-axis. Okay, that was one of our transformations. What was the other one? What was it? Oh, good. Yep, vertical stretch. not stretch. We multiplied by 1/4. It actually shrunk it. Vertical shrink by 1/4. Okay, and there's our two transformations. Reflection over x-axis, vertical shrink by 1/4. Let's do another one. X to the 5th. And we have two transformations. Let's talk about our transformations first. We have one that's multiplying, and it's tucked into the parentheses, so it's in the house. Multiplying is a stretch or shrink. In the house is horizontal. So that will be a horizontal. Stretch or shrink. It's a shrink by the reciprocal of 2. What is the reciprocal of 2? That's right, 1/2. So it's a horizontal shrink by 1/2. And then what does the -3 do? Vertical translation down 3. So we've got our two transformations. Now we got to figure out what to do with the points. Horizontal shrink by 1/2. We're going to multiply just the x value by 1/2. The down 3, we're going to subtract 3 from the y values. So before we do either one of those, we are going to figure out the parent function numbers. Parent function is x to the 5th, so -2 to the 5th power. Ooh, that's an odd power, so we would have 5 negatives. That's going to give us a negative. 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32. When you multiply an odd number of negatives, you get an odd answer. When you multiply an even number of negatives, you get a positive answer. I think I said odd, I meant negative. When you multiply an odd number of negatives, you get a negative answer. Not sure if I said that right the first time. All right, -1 times -1, 5 times. That's going to be a -1. 0 to any power. 1 to the 5th power. 2 to the 5th power. Put those on your graph. Take all of these x values, multiply them by 1/2. Take these f of x values, or the y values. Don't multiply those. I didn't put parentheses around that. What are we doing? We are subtracting 3. Right, figure those out. Here we go. Multiplying by 1/2, 1/2 of -2, 1/2 of this, 1/2 of this, and 1/2 of this. Time to make a graph. Remember that odd functions, odd degree functions, will have the ends going opposite directions. So there's one up and one down. It looks a lot like an x cubed, but the numbers change even faster. So there's our parent function. Let's graph the other function. -1 goes with -35. -1/2 goes with -4. Zero goes with -3. That's probably the most important part of our new graph, is that that middle 0, 0 has shifted down 3 units. And then 1/2 goes with -2. And 1 goes with 29. So that's going to be way off our graph. But it's all about that it's more narrow than it was before. Whoops. And that it shifted down 3. So that gave us that horizontal shrink by 1/2. So it got squished in horizontally and shifted down 3. And there's our new graph. can always check on Desmos. All right, let's look at how to set these up. If f of x is x cubed plus x squared plus 1, write a rule for g, and then graph each function. Describe the graph of g as a transformation of the graph of f. What does multiplying just x by a negative do? Multiplying by a negative gives you a flip, also called a reflection. All the other ones we had were up front, and those were over the x-axis. This one's inside, so that's a reflection over the y-axis. I already figured out our starting function, x cubed plus x squared plus 1. If I put in a negative 2 and cube it, I get negative 8. Negative 2 squared is positive 4. Negative 8 plus 4 is negative 4 plus 1 is negative 3. So I put that number in my table, and I did it again with negative 1, 0, 1, and 2. So these are the numbers for the parent function. Or starting function. I shouldn't call it. It is not a parent function. It is a starting function. It is our f of x that they gave us. So I have those numbers all set and ready in my table. Reflection over the y-axis, we are multiplying just x by a negative. So if we multiply negative 2 by a negative, we get positive 2. Multiply by a negative, multiply by negative 1, multiply by negative 1, multiply by negative 1. So those will be our new points on the graph. 2 goes with negative 3. 2 goes with negative 3. 1 goes with 1. 0 with 1. Negative 1 with 3. And negative 2 with 13. So it flipped over the y-axis. There it is. It's a reflection over the y-axis. Okay, the next one. 3 times f of x. What does multiplying by 3 do? That is a multiplying, so that's a stretch or shrink. And which kind? Vertical. Vertical stretch by 3. Three times the function, so f of x is the y value. So we're going to take this y value, multiply them by 3. So now when we graph it, the x and the y, we're using the outsides. Negative 2 goes with negative 9. Says it's a vertical stretch by 3. Negative 2 goes with negative 9. Negative 1 with 3. 0 with 3. One goes with 9. And 2 goes with 39. We're not going to find that one. So it stretched it vertically. It went higher and lower really fast, a whole lot faster. Our middle point was at 0, 3. That's an important one. All right, I'm going to touch up this graph. Remember, the most important points on a graph are the intercepts, where it crosses the x and y axes. Make sure you get those right. All right, the part we haven't done yet that is also very important. We have to be able to write the rule for g. right? The rule for g. So we have to create the new function. So g of x equals f of negative x. So with f of x, we have to replace each one of the x's with a negative x and simplify to get our g of x. Copy the f of x function, take out your x's, replace it with a negative x. Do some simplifying. Negative times a negative times a negative is a negative. Negative x times negative x, so negative x squared is a positive x squared. And the 1 didn't change. So there's our new rule for the g of x function. That's part A. Now try part B. Here we're multiplying by 3. Multiplying the entire function by 3. So 3 times whatever f of x is. Simplify. We have to get rid of those parentheses. So distribute, multiplying by 3. Now that we have an equation, it's easier to even check our graphs. We can put this equation into Desmos and the original f of x and compare. And that's example 3. Example 4. Let the graph of g be a vertical stretch by a factor of 2, followed by a translation 3 units up of the graph of f of x equals x to the 4th minus 2x squared. Write a rule for g. Vertical stretch by 2. So whatever f of x is, we want to do a vertical stretch by 2. That's multiplying by 2. And it says followed by a translation 3 units up. So we need to complete this vertical stretch by 2 first before we worry about what's next. So 2 times the function and simplify it. This is our new function. They want our final answer to be g, and we've already used f, so we'll call this h of x. And that's what they did on the graph too, so we'll just follow along with what they did. So we have 2x to the 4th minus 4x squared. Then it says, followed by a translation 3 units up. 3 units up, what do we do for that? We add 3. So our g of x is exactly what we already had with a plus 3 on the end. And then you could graph all 3 equations, the original, this one after we multiplied by 2, which is our h of x, and the g of x, and see that we got a vertical stretch of 2. Notice the 0, 0 stays 0, 0 when you multiply, but it stretched it out, and then the shift up 3. Sometimes the graphs help, sometimes we don't need them. I don't think I would have taken the time to graph this one, but you can. There is our g of x function for example 4. Monitoring progress, just describe the transformations. Pause your video, write down what you think the 3 does and the minus 1, and then go to number 2. Tell me what the 4 does and the 2 does. Pause your video. Write down some answers. On your mark, get set, go. I went to unpause my video and it wasn't paused. So I think I paused when I meant to record and recorded when I meant to pause. So I'm going to back up the screen. Example 4, just a quick brief overview. If you haven't seen this yet, pause your video right now and take a long look at it. But we did a vertical stretch by 2. So we took the function they gave us and multiplied by 2. And because it said followed by, we needed to simplify that first before we do what's next. The next thing said followed by a translation 3 units up. So we needed to add 3 to that function. All right, so there was example 4 in case I didn't record that yet. Monitoring progress. Describe the transformation of f of x. So you could pause here and take a look, write down what you think the 3 does and the 1 does. Here's your answers. And for number 2, here's your answers. Writing rules. Let f of x equal this function, and g of x is the opposite of f of x. Write a rule for g. Describe the graph of g as a transformation. So what kind of transformation is this? That is a reflection over the y-axis. Oh, x-axis. The one that's by the x goes over the y-axis. The one that's out front goes over the x-axis. This is the more common one. We flip things over the x-axis fairly often. All right, so that means we have to multiply the entire function by f of x. So the entire function by negative. So negative, copy the function. Simplify it. So you're distributing the negative. It's going to change all the signs to their opposite. And this is your new g of x. G of x equals negative x to the 5th plus 4x minus 6. Try the next one. Pause your video. Horizontal stretch by a factor of 2 means we're going to have to multiply just x by the reciprocal of 2 for horizontal stretches and shrinks. You multiply by the reciprocal inside the house just to the x. So using our function 8x cubed plus 3, replace the x with a 1/2 x. And x was being cubed, so now 1/2 x is being cubed. That's 1/2 times 1/2 times 1/2, 1/8. And x cubed, 1/8 times 8 is just 1, so that goes invisible. 1x cubed plus 3. Now followed by a translation 3 units to the right. So 3 units to the right, so our g of x is going to take our h of x and move it 3 units to the right. 3 units to the right, that goes just to the x, and it's subtraction. In the house, opposite of what you would think would be. It's always something tricky about the x's. So replace x with x minus 3. We are going to leave it just like that for our final answer. We could use Pascal's triangle and expand this, or multiply it the long way, x minus 3 times x minus 3, get an answer, and multiply by x minus 3 again. But we're going to leave it just like this. We did all of our transformations, so we have our new function. All right, describe the transformations. What does this do? What kind of reflection is that? Over the x-axis or y-axis? That one's over the x-axis, good. And what does this one do? Subtracting 3? That's going to make it go down 3. Awesome. Lots of examples. Go work on your big ideas assignment 4.7. The page that you want to keep in mind as you're looking through it, a good summary page is this page right here. Reminds you of what adding and subtracting is a translation, multiplying is a stretch or shrink or a reflection. Reflection when it's multiplying by a negative. Horizontal stretches and shrinks are in the house. Vertical stretches and shrinks are multiplying the entire function by a number. So you might want to have your notes open to that page as you work on your assignment. Have a great day. Thanks for watching.